Let's see. Are we ready? Are you ready? Faye, are you ready? Okay, hold on. I'll wait. Everyone out in the interwebs right now are waiting on you. You good? All right, class. Oh wow, that's weak sauce. They're waiting all that time just for that. Fine, let's go on. Anyway, all right. Function is integratable on an interval containing the numbers a, b, and c, which is basically your x values. Okay, Christian. Then the integration of the whole thing could be broken up into parts. And quite often we're going to actually have to use this. So, in, I don't know, layman terms, in normal people speak, Anyway. So, this right here, A to C, would be this area here. So I have that area, and I'm going to add together the other area. So it's basically, I'm adding two areas together for whatever reason. And it's going to get kind of weird from here, just because. So, I'm gonna play with that formula. So if I say from integration from a to b of f of x dx is equal to the integration of a to c f of x dx plus c to b f of x dx, wouldn't this be the same, because this equal sign right here is where it's at. Wouldn't this be the same as integration of a to b f of x dx minus integration of a to c f of x dx is equal to integration from c to b f of x dx? Is that the same? Is that still true? No? Okay, let's.
I didn't see the minus sign.
You don't see the minus sign?
I didn't see the rest of it.
Okay, let's do this. Let's say that this right here is 9. Let's say this one here is 11. What's their total? The total from A to B. What's the total area? 9 plus 11, which gives me 20, right? So we would say that 20 would be equal to 9 plus 11, right? Okay, what if I do a little bit of algebra? Subtract 9, subtract 9. So is 20 minus 9 equal to 11? Yeah. So this property works because this equal sign right here. So can I finagle my property? Can I move it around? Yeah, I can move it around to try and find out our missing, or sometimes having to rework this in different ways. So it does work. So here's one. If f of x is integratable on the closed interval from 2 to 7, which is the whole thing, then 2 to 4 plus 4 to 7. So right there. So is that the same as what we just had there? Okay, but we're giving it some values this time. So from 2 to 7, or adding together both pieces together, that's gonna give me all the way from 2 to 7. Now, this is where that weird thing comes into play. So, closed interval 3 to 25. Isn't 3 to 25 the whole thing? Okay, 3 to 25 is the whole thing. So that's this one right here. But what happened right here? Okay, what's wrong with that one? What looks wrong? What's wrong with the bounds that it gives us?
Well, if it's like from 3 to 25, I was kind of spacing out, but, you said to like add them.
Okay, but what's wrong with that one that I circled last? What's wrong with this one right here?
Oh, it's oriented inverted.
The bounds are backwards, right? We had a problem like this when we were going over the notes the other day. What happens if I put my bounds backwards? What do we change? The bounds are backwards, I changed something.
Oh, is that what we were talking about yesterday?
Yeah, the forwards and backwards, right? Forwards and backwards. So what would it be if I'm going from douche rows back to here? So I start here
Right.
and I walk over to douche rows. Okay? What type of velocity would that be? That's a positive velocity, isn't it? Okay, what if I go from douche bros back to here? That's a negative velocity, right? So what we're doing on this one here is my lower bound is 25 and my upper bound is 10. So that means I'm going from further away backwards, right? So how can I change that? How can I fix that? It was in one of the notes.
Absolute value.
Nope, not the absolute value. Good
The
thought.
bounce will take the negative.
There we go. Flip the bounce and change it to negative. Flip the bounce and change it to negative. Because that means I'm starting at 25, then I'm going to 10. So that means I'm starting at the far end and going to 10. So I'm going backwards. So this would be, let's see, so 3, 25 g of x minus 10, 25 g of x dx. Okay, so now what is this actually doing? This is taking my whole value from 3 to 25 and I'm subtracting 10 to 25. What's going to be left if I subtract 10 to 25? I'll draw it for you. Have a graph. Okay, so I have the whole thing, which is my 3 to 25. That's the total area, right? That's the total area. So whatever it is, so it's A1 and A2, okay? The total area of all of that. And I'm going to minus area of, where did it say? 10 to 25? So I'm going to take away, so I have the whole thing already, which is here all the way to here. And I'm taking away this, 10 to 25, right? I take away that, what's gonna be left? 3 to 10. Does that make better sense now, that showing it like this? So this is going to give me my integration from 3 to 10. Integration of 3 to 10 is there. So that's manipulating the bounds as long as I'm not on my phone and zoning out. But it's almost like we're addicted to that. Like every 3.5 seconds, you have to look at it. All right, any questions before I move on? Or are you texting questions or asking ChatGPT to copy down these notes for you? Oh, okay. And hopefully this drawing, look at my amazing drawing here. This didn't help?
Pretty good, actually.
I know, right? That's amazing. That's like gets an extra zing how amazing it is. Find the area under the graph. Okay. So from 0 to 15. So I'm gonna have to actually do this in 2 different parts because these are 2 different functions. Right? They're 2 different functions. So I'm gonna have for the whole thing, so integration of from 0 to 15 of f of x dx is going to be equal to, my first part of the integration starts at, this is where the piecewise comes into play here. From 0 to, integration 0 to 10, and that is going to be x squared dx. And then I'm going to do the next one, right? So it would be plus the integration from 10 to 15 of 100, right? That's my function. 100 dx. Now hopefully writing it out like this, you could see it, visual it, and let's go ahead and do the integration now. So that's going to be, what's the integration of this one? X cubed over 3 from 0 to 10 plus what? Say it again. 100x. From so top minus bottom, it's going to be 1,000 over 3 minus 0, right? And then plus sign, then all of this, when I do that, what's that going to be? 1,500? Minus 1,000. So that's going to be what, 500? So plus that. So what's that going to be? If it's 500 times 3, 1,500 over 3, plus that one, so it's going to be 2,500 over 3. Feel free to correct me on this because I quite often just throw out numbers. I make it up as I go, and I hope someone catches my math. Because they roast me over the coals if they find it online, and they just like grill me on it. It's bad.
Is that 1,800?
15. My 5s are kind of wonky. Oh, this right here? Ah, there we go. 1,500 right here, yes. Sorry, that's 1,500 because 100 times 15 is 1,500. Ah, it's bad, but you know.
That's not a 5. That's not a 5.
You're not a 5. Wow, okay. That burn just, was not a burn, that's like one of those, like, yeah. Almost like we have to keep looking at our phone every couple seconds too, it's weird. Huh?
I'm checking my Teams message.
Oh, wow, do you have a guilty conscience?
Yes.
Okay, maybe at that current moment in time, I actually wasn't talking about you. I was talking about the other person that has like this OCD, this obsessive compulsive disorder, is stare at their phone once a minute, every minute, no matter what, even if it's not going off. Be like, oh yeah, I'm just checking the time. Even though, like, those people that are not in my classroom, the clock is digital and it's above my head. So you just have to look in my direction and there's a clock.
Okay, well, usually you don't have my glasses on, so I can't see that far.
Okay.
Yeah, wait, question. So, for this example, we're saying f of x is already like the,
It's a piecewise function.
so do piecewise functions work differently for integration?
No, cause you just do each part individually.
Because integration, we find the anti-derivative, right?
Yeah.
But you just use the regular.
Okay, but if I was gonna do the derivative, I would do the derivative of this and the derivative of this, because they have different slopes, right? So the slope of this would be different, the slope of this would be different, and so I would find it at each point in which that is different. Yeah? Yeah, piecewise are broken up all, by whichever piece you're talking about.
It just says 100, right?
Yeah?
So why do you have 100x? And when on and I was like, he did, I misread it. My bad.
Okay, no worries.
It is x cubed over 3.
Oh, you didn't do the second part?
I didn't see the second.
Oh, okay, yeah. Alright, let's see what we got here. Ooh. Alright. Now we have a bounded function starting from -1 going to 4. So this one right here. So if I'm finding the area under this, this one's gonna be interesting. What if I draw this? Would that help? Okay, so if I draw this. Alrighty. So from -1 to 0 is e to the x goes to 1. So that's 1. So that's gonna be like, is it like this here, and at 2 it's 5. 2, 3, 4, 5. Solid dot right there. And for this other one, it's x plus 2 to here. And starting at 0 going to 4. 2 up 1 over 1. So it's gonna look kinda like this. I'm gonna have 3 parts. And I'm kinda just winging it on that e to the x, cause e to the -1 is actually 1 over e to the 1 which is less than half, and so I'm just agreeing with it. Anyway, so we have three parts right here. So I'm gonna take the integration from -1 to 0, and that's gonna be right here, e to the x, plus integration of where am I at? 0 to 2 Alright, anyone see a problem here? Hmm? One of the functions,
It's not continuous.
yes, it's not continuous. I think that's what you said, right?
No, I was just saying that the functions are the same ones before.
The function is what? I can't hear very well, especially right here. There's a fan that has like this humming.
It says x plus 2, and it says x plus 2.
Oh, wait, what?
Is it supposed to be x plus 2?
No, but why are there two x plus twos?
Yeah.
What happens right in the middle of that from 0 to 4?
So 5 doesn't exist then. Oh wait.
What happens there? What's this thing called? Not an asymptote. Very good. Discontinuity. It is a discontinuity there. So there's a discontinuity, but isn't this area right here, so let's call this one over here A1, A2, and A3. There's a discontinuity, so this goes all the way up into this point right here, but it's not equal to right there. It's not equal to there. So what's happening to the area there? We're getting the area all the way up into this point, but not to that point too. So it's not really equal to 2 at that point. So the discontinuity is right there. So that's why I can't go from here to here, because all the way in between is not continuous. So I can go to this point right here, which is going to be approaching 2, get really, really close to 2, but not be equal to 2. So we're setting it up like this because there is a discontinuity in there. So I have to break it up around the discontinuity. So we could still get A2 and A3 because it is not continuous. So now can we do it? Say yes. Alright, integration e to the x. E to the x. So I'm gonna change up my colors because I like that do that. What's this next one gonna be?
X squared plus
Over 2. Plus what? 2. X, yes. It's almost like trying to talk to someone, but they got their hand on the phone again. But I don't know what the hell happened there. And that goes from 0 to 2. Plus one, which is gonna be x squared over 2 to x from 2 to 4. And so anything to the 0 power? 1. So e to the 0 is 1, and then that's going to be minus lower bound e to the negative 1 plus, this is going to give me 2 squared is 4, divided by 2 is 2, plus 4. Minus lower bound 0, 0. Right? Okay. And now I'm going on to the third one over here. So it's plus upper bound, which is going to be 4 squared is 16, divided by 2 is 8, plus 8. Minus the lower bound, which is going to be 2 plus 4. So let me see. That's 6, and that's minus 6. 16, 17, minus e to the first. To negative first. Ooh, I am not going to be able to finish today. Before I get into this one, I think I'm going to pause this one for today, and we'll pick it up next week. We'll pick this up next week, so, because this one is its own strange animal. Okay? So, with that being said, everyone's going to like, share, and subscribe to get some of this other homeworks done that you owe me. Otherwise, I'm calling your mama. And I'm going to put her on the speakerphone in class. Okay. Anyway, like, share, and subscribe.